So this presentation is about database optimization, and I will just cover some of the most important problems, just focusing on two main problems, and I'll talk a little bit about monitoring the performance of your app. So let's get started. All right. So this presentation is for junior to intermediate developers mainly. Maybe for expert developers, they can maybe just refresh their memory, but I'm probably very confident about it. And yeah, so by the end of this presentation, I hope you'll be able to describe the two most common ways of improving the response time of your app, and also secondly to understand how to monitor app performance. All right. So there are a couple of reasons, why your app is can be, loading, have slow response times when it's loading pages. Most of the problems come from the database layer. Of course, there can be lots of too much memory or variables in your controller code, or I don't know, messed up views, but it's mainly due to your database layer. I will be mainly covering the N+1 query and the database index issues. And if you'd like to look research on your own, you can look up caches and poor memory management on your own later. But yes, I'll be covering the two main topics, which are N+1 queries and database indexes. So, all right. So just to give you, a bit of background. All right. So imagine you are online and you have some time during your break at work. So you go online and you search something that you want to browse online via Google Images. In this case, this can be a bunch of pictures of dogs. All right. And if you notice as you scroll down, pictures don't load immediately. Obviously, there's a few milliseconds before you scroll down and you're seeing new pictures. This is an example of lazy loading where you only load content when you need it. And of course, this is very important for reducing loading times, and especially important for mobile users. All right. Now, eager loading is the opposite, and we want to use eager loading in certain cases, but in most cases you don't want to load everything at once because it's going to slow the page down, and that's a bad user experience. All right, so you don't want to load pictures that you don't have the chance to see. You don't want to load resources that waste bandwidth. So N+1 queries. All right, so just a quick review. So building off of that concept, we have N+1 queries. And the main important message here is to understand that if you're still working on a small scale app, you don't need to worry about it. Along with database indices, if it's only a few records, you don't need to worry about it. But if you want to scale out your application, or your company wants to scale out your application, you have to be concerned with the number of queries that your application or database is making, because the more queries you make, the longer it will take to load, slowing down the user response, slowing down the response times. So the N+1 refers to the number of queries that code like that on the screen will generate. I know it says user, but just imagine the user to be a child object in an associated relationship with the recipe. It can be it's just a parent-child relationship. User doesn't really make sense to me, but just imagine user as a child of the recipe. Yeah. All right, so this is the SQL queries that you'd expect to be generated from this. And this can be improved by reducing the second part of this code, SQL code, into one single select query. All right. So if you look at the code here, we have the top part where it selects the first model, and then the second one individually selects each associated child. All right. We don't want that. We want to pick out all the children that of the parent object or the parent model all at once, right? And it doesn't seem like a big problem now, but if you had thousands of records or hundreds of children records, then it would definitely make a significant difference to loading time. Quick pause. I just wanted to ask something with Sorry. That's fine. Yeah. Have an issue. Is that all right? All right. So the solution is very simple in Rails. In Rails, all you need to do is just to remember to include, sorry, I was going to say includes, but make sure you use or check if you can use includes as well as, other options like eager load or preload, but mainly like using includes is fine. And the reason you want to do this is because as opposed to lazy loading each record, just like the analogy that I made with the loading dog pictures, includes forces the application to load both objects tables at the same time. All right. So instead of loading one model table and then checking the related database or associated database every time it iterates through the different records of the parent, we're going to load both at the same time. And what this does is it reduces the number of queries to 2. Right? So if you look at here, so we have 1 for the parent and then 1 for the second model or the associated child model. And you see it can retrieve all of the records for the second model all at once, saving us a lot of time, right? So here's just a meme summary of that. Yep. So we don't want multiple queries. We want to reduce the queries as much as possible. And the alternatives to includes are things like preload and eager load. There's some small differences between them, but no need to be pedantic, you know what I mean? Yes. All right. So my second example is for Kohl's. All right. So imagine they redesigned the store layout. You don't know where to get your favorite items anymore. So you're wasting a lot of time walking around the store. I know the example that they use is like you want to check the back of a book, but I want something more every day. All right. So what do you know? Now they have this brand new idea. When you walk around with a trolley, you have a list of the different items. So you don't even need to check at the front of the aisle. You can just look down at your trolley and you know where to get your items. And this is far away. I've never seen this in person, but you can see this is Joondalup. So maybe it's just like someone photoshopped it or something. I'm joking. All right. So indices are actually like more. You can apply indices beyond the primary and foreign key, right? I know most beginner developers may be like, oh, I got to add the indices to foreign key, and that's good. That's the most common use case. But the important thing to remember here is that you can add indices on columns that aren't foreign keys or primary keys, right? And I've made 2 key criteria or 2 important points you need to remember to decide when or not to apply an index. And that is number 1, if there's lots of records, lots of data, like for example, thousands or tens of thousands of records, and the number of records being retrieved is like high, then the bigger the number, the more useful an index will be, right? So if you only have a few records, you're only retrieving like 1 or 2, you're not going to save a lot of time, especially if it's a small application used by a few people, right? But if it's a very big app used by, very big companies, then you don't want to scan the column multiple times. And that brings me to the second point. So think of the times where when you're loading a page, it connects to the database and it forces a table scan. And what I mean by table scan is that it has to sequentially go from top to bottom and check every value instead of directly, for example, with the primary key, selecting one record and then returning that as a value, right? So that's where the efficiency gain is at. And the reason why I made this ingredient is because I thought it makes more sense than user. You can see that as a child, that as a parent. But yeah, so foreign key would be the most common case example that you would see, right? Now I think for junior and intermediate developers, it's very important to have like kind of like a visual understanding of what happens when you actually add an index to a column, right? Because you can automatically generate it, just command line, add index, add reference, right? But you need to understand that when you add an index to a column, for example, if it was the name of the recipe, what it really does is it generates like a mini table corresponding to the original model. On the left-hand side, you have the value for the name of the recipe. And on the right-hand side, you have, or on any other value. On the right-hand side, you have the pointer to the record that is in the original table to which you added the record, right? So for example, pasta could be pointing to, the record that has primary key number 2, right? And this is important because I'll explain later why, it affects the efficiency. But anyway, just an interesting fact, there is a non-clustered and clustered indexes. All the indexes that you add to the columns in Rails are non-clustered, right? And you see it's sorted on the left-hand side, right? But the thing about non-clustered ones is that, they are not corresponding directly to the order of the original table, right? And there's only one that can be corresponding, and that's clustered index. Can anyone guess? Raise your hand up if you can guess which is the clustered index in Rails. Yep, ID. And the thing is, you can only have one clustered index on a table, because if you sort another column, then that removes the order of the primary key. And you can't remove that voluntarily in Rails. You'd have to go database level and issue a command to do that. Not necessarily, but it's important to understand what you're doing. Like the more, the better, right? All right, now there are common use cases. Like you don't have to worry about all of these, but I'm not going to even go over them. But it's important just to remember unique values, anything that requires sorting, anything that requires where commands in the SQL. Yeah, that's where you normally would have them have the potential to apply them. Anyway, so just going back to the summary, meme-wise, table scan, index, query, very good. And going back to the explanation of the indexed mini table. So indexes aren't always good because it's good when you're scanning a table and you're cutting down the time. And that applies to the select and where queries. But you have to understand that every time your table is updated, they have to correspondingly update that mini index table as well. So if you are, inserting or updating records, the computer has to application internally update that table as well, right? So it's not really useful for small apps, can even hinder performance where it's not relevant, right? All right, so I made this mini flow chart. I mean, it's pretty common sense in my opinion, but I mean, after this, I'll go over the gems, but it's important just to talk about monitoring and benchmarking performance. All right, so your application is not doing well enough. All right, and normally like the benchmark they say is like above 200 milliseconds, but it depends very on cases. Like if you're working in the emergency department and like in healthcare and you need a really responsive app, then sure, maybe it has to be really fast, it has to be real time, right? But if you're making like an enterprise human resource app, it's like probably not a big stress. Anyway, so I like to you should probably isolate the page and connect it with the controller that's responsible. Yeah, connect it with the controller that's responsible. And go to the database, go to the logs where it has, SQR, where or select or insert commands. Take a look at these commands, see if there is a suggestion, anything that suggests the n+1 query, or anything that suggests, like frequently queried columns that could have an index added to them, and then apply one change at a time, test the performance after that, and then see whether or not it's useful. So for example, when we're talking about indexes, you don't know, for example, for sure whether or not adding an index would be useful. Just isolate that single controller action and then add it, test it. If it improves performance, great. If it doesn't, just roll back and no one's hurt, right? So that's if you really want to be thorough with your reviews. Alternatively, you could just go to your boss and be like, it's better if we just have like some third-party software. AppSignal is recommended by GoRails.com. That guy, who makes a lot of videos. I recommend for junior or intermediate or interpersonal projects to use the free tier of New Relic, which is also a third-party But basically, all they do is they give you a constant kind of like a record of the amount of time that each page takes to load. App Signal goes further by giving you like an alert in real time. And in terms of specific problems, Bullet Gem, they say, is kind of like, I'm not sure if Bullet Gem is good, but they say it addresses, helps identify N+1 queries. And this obscure gem, LolDBA, suggests columns that should be indexed. Now, I'm just giving you examples. I'm not saying that I recommend that you use them, but it's important to understand the concept behind it, and understand there are some gems that address that. Anyway, yeah, so I'll upload this PowerPoint online on my LinkedIn. That QR code is just a link to my LinkedIn. I haven't updated it, so don't judge me. And yeah, that's it. Sorry for taking so long.